Hello and welcome to this lesson about direct variation. The learning target for this video is finding the constant, writing equations, and finding missing points, all in the context of direct variation. So first let's address what is it. Direct variation just means a proportional relationship exists. So proportional relationship. There you go. Okay, proportional relationship. And the thing you have to know with direct variation is that it comes with sort of a little mother equation, which is y equals kx. So you see varies directly, you got to think y equals kx. If you see proportional relationship, again, think y equals kx. And so what we can take from this is we can use some of our skills to solve literal equations and get that k equals y over x. And so this is a tool that we'll use for a lot of the things we have to do with proportional relationships, with direct variation. And so the things that we will have to do, let's make a little to-do list here, is 1, find k. 2, you will need to write equations, but they all have to be in the form of y equals kx, and in order to do that you have to usually find k first. So I was just kind of building on it. And then 3, there's this problem where you have to end up find a missing coordinate, and I'll show you an example of that a little bit later. Right now though, let's talk about finding k. Now, there's two ways this could happen. You could either have to do it from a graph, or you will have to do it from a table. Now, the table is the easier one, so let's start there. Let's say you have an x and a y, and you're given, or an xy table, and you're given a bunch of x values. So let's just say 3, 6, 9, 12. And then you have 15, 30, 45, and 60. All right, and so what you have to do is find k. Well, in order to solve this problem, and it works for either one of these, you have to use k equals y over x. So for the table, take your smallest value, find the y, find the x, and go y over x. And guess what? You found k. K equals 5. Box it, walk away. Now with a graph, it's the same idea. Now what's going to happen with these proportional relationships is that they don't always have to be positive. They're mostly going to be positive, and they're always going to go through the origin. So that's one thing. It's like they're definitely going to go through the origin, and again, they're mostly positive. And so here you might be given a graph, and it could look like this. And you have to find k. Well, again, we're going to use this trick right here. K equals y over x. All you have to do is find one of the points. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. So we have 3, 7. And go y over x. 7 over 3. And here's the thing. That doesn't really reduce that well. I mean, 7 over 3 is a great reduction of 7 over 3. So you box it, you walk away. And that's all you have to do is for finding k, is just go y over x. Now, when it comes to writing equations, this is where you have to do a little more work. And that more work is just adding that one extra step of then making it a new equation. Now, this one has sort of 3 categories. We'll address the first 2 right now. So we have the graph, and then we have the table. So for the graph, let's say we have this. Oops, my points did not get written down. There we go. All right, and so, whoa, slow down. Through the origin. All right, we have 2, 1, 4, 2, and 6, 3. So first you have to find k. Well, k is equal to, k equals y over x. And so for the graph, k equals 1 over 2. and you'd get the same thing if you did 3 over 6, 2 over 4. So the final step is to write the equation, y equals 1/2 x. And there it is. Similar idea with the table. So we look at our xy table, and this time let's say we have 10, 11, 12, and we had 20, 22, 24. Use k equals y over x, 20 over 10 is equal to k equals 2, so y has to equal 2x. Now, the final version of writing an equation might come in the context of a word problem. And so what I want to talk about with word problem really quickly is the difference between x and y. So x is considered to be the independent variable. Independent variable. And y is the dependent variable. And so a classic example to kind of help you understand like which one is which. So first of all, independent means it's kind of driving the problem. Great example of independent is pretty much time. Like, so you have to work really hard to write a word problem where time is not the independent variable. And then the dependent variable could be something like money. And so just think about, an hourly wage. And that's a great example of independent, dependent, in fact, a proportional relationship. So let's say you're getting paid $12 per hour. Well, if we were to make a little XY table out of that, X and Y, first of all, we have to think, what's the independent thing? Or actually, sometimes it's easier to go with what is dependent. And how much money you're getting paid depends on how much time there is. So our X variable in this case is going to represent time, and the Y variable is going to be the money. And so if you work 1 hour, you get $12. 2 hours, you get $24. 3 hours, you get $36. And so if we use the whole k equals y over x, we would end up getting k equals 12. And so the equation here would have to be y equals 12x. Walk away. Now the thing is, it's going to be disguised a little bit better than this. And it might be something like this right here. Tom got a summer job. If he was paid, let's say, $48 for a 4-hour shift. That's not how you spell shift. There we go. And he was paid hourly, and he was paid hourly. Write a direct variation equation modeling his pay. So it could be something along those lines. And so here you have a couple of numbers that are hidden, and you have to think, all right, x and y, because depending on how you set up x and y, you're going to get a big difference. If you flip x and y with the table example here, you'd end up getting y equals 1/12 x. Far cry different than 12x. So that's what we have to think. What is the dependent thing? What is relying on something else? And how much money he's getting paid relies on how long he works. So with that, and unfortunately with word problems, I can't be more sort of general, or can't be more specific. You have to be very vague and just kind of equip you with some ideas. And so it's all about trying to find the independent and dependent concepts and then associate those or put those numbers in the right spot to then solve using a formula like k equals y over x. All right, finally, let's talk about finding missing points. So several ways, like several different looks you could get with this. So let's say for the first example, you're told k equals 4, 2, comma, y. And you got to find what y is. So you use the idea of y equals kx, y equals 4x, and then what you can do is take this 2 and you can plug it into x. And so y would have to equal 4 times 2, which is 8. And likewise, if we wanted to, we could, have the same problem. K equals 4, and then you have x, comma, 8. What is x? Well, y equals 4x. Now you put 8 in for 4x, you solve, x equals 2. So that's one look. And you're going to be told that this is a direct variation problem. Or that there's a proportional equation, and then you'll be given this information. It's not just out of the blue. You have to figure this out. Like you'll be given the context of direct variation. Another example. Let's go back to blue. You might just be given 2 points, and then you might be told these points vary directly. And so again, once you see very directly in your mind, you have to be thinking, y equals kx. And so they give you the points, and it could be something like 2, 24, and 3, oops, spoil, x, 36. Well, just pretend I didn't say 3. I don't recall saying that. And so y equals kx, you use this point, 24 is equal to 2 times k to find out what k is. K equals 12. Then you go back to y equals now 12x instead of kx, and you plug in 36 for y. So 36 will go in there. And that gives us 12x, and x equals 3. So that's another look. You're going to be told that the 2 points vary directly, but one of them is going to be missing a coordinate, and you have to find it. Another way, you can just set up a proportion. You could go 2 over 24 is equal to x over 36. That would work out as well, because you're hinging this all around k, and they both share that same k. So that's another way you could solve that problem. And then just to show you yet another look, and maybe with a little bit of harder numbers, same idea. So these points vary directly. That's the language you'll tend to see with this. And so let's see, we have 30, 5, and 72, y. So again, 2 options. I'll show you both of them. Option number 1 is y equals kx. Use this. Now be careful. I can do this to kind of make things tricky. 30 is the x, 5 is the y. So 5 equals k times 30. So k actually equals 1/6. Then y equals 1/6 x. Plug in the 72 for x. So y equals 1/6 of 72. And that would give us y equals 12. That's one way. Other way, 5 over 30, or actually, you know what? Let's just mix it up. Let's have fun. Let's go 30 over 5. It doesn't matter. Is equal to, as long as we're consistent, which doesn't matter. 30 over 5 is equal to 72 over y. So I could, do some cross multiplying, but I see that this is going to simplify right now, so I'll do that. 6 equals 72 over y, times both sides by y, or do actually some cross multiplication. Just move the 1 over there. Those cancel out. 6y equals 72. Y equals 12. So again, multiple ways you can go about it, but this is how you end up solving for these problems with direct variation, and it all hinges on y equals kx. And then as a result of that, k equals y over x. So if you have that in your back pocket, you can solve these problems. It might require a little bit of thinking with word problems, but I think I did a good job of showing you some different looks for finding like missing coordinates, what it's going to look like with a graph, how you have to write an equation, or how you even have to identify and find k. So good luck with your homework and practice, and let me know if you have any questions.